What is continuous compounding? Well, we learn in basic TVM that compounding is taking the interest, the annual interest rate, and dividing it into smaller periods. So just to do a little recap of that, if you took, this is timeline represents a single year, okay? So this would be 1 year, and your rate, let's just say is 10%. Now, if you compound only once per year, that means that the interest is calculated only one time per year. So if I were to put $1,000 today, nothing would happen, but after 1 year, you would gain 10%, right? So you would have $1,100. 10% is $100, so you'd have $1,100. Now, the more often I compound, so let's say I compound twice per year, right? So same thing, your rate is 10%, but you're compounding, we usually use a symbol M for that 2 times per year. What does that mean? It means we take our 10% and we cut it in half. So 5% here, 5% here. So instead of having to wait a full year, you actually get your first interest in 6 months. So you deposit $1,000 today, you wait 6 months, oh, you gain 5%. So plus 5%, right? Now we're at $1,050. And then you go another 6 months, you get another 5%. Now we're at $1,102.50. So what happened? Still the same 10%, but because I compounded more often, I actually ended up with a little bit more money. And the more often you compound, the faster your money will grow, right? I can do this again with 4 compounds or 12 compounds. Now, what if the compounding happened an infinite number of times? It's hard to visualize, okay? It's actually impossible to visualize. So try this. I divided this into 2 periods, very easy. Now, what if I took a year and I divided that year into 1,000,000 periods, right? So I took my 10% and divided it by 1,000,000, right? So let's see what 10% divided by 1,000,000 is, 0.00001%. But I gained that 1,000,000 times over the year. So you're taking your year, kind of like how I did it here, cut it in 2, but I cut it into 1,000,000. And you can now start to visualize it. I can even say every second, right? What if your interest was compounded every single second? So every second you got a little bit of interest. And once you can fully wrap your head around that, go even smaller. Every millisecond, go even smaller. And at some point you get to infinity, right? The period becomes infinitely small. And that's continuous compounding interest. It's an infinitely kind of revolving interest period. So it's the fastest amount of growth. There's no more, you can't get faster than infinity, right? That's continuous compounding. The formula that you need to know is A PERT. That's how I remembered it. A is your future value. P is your present value. P is your initial, your principal. E is just a button on your calculator. It's the exponential variable. It's kind of like pi. It has a value. It's like 2.71 or something. R is the rate, the annual rate. T is time in years, okay? So let's go through 3 exercises on this. You just invested $10,000 into an account earning 8% interest compounded continuously. 8% interest compounded continuously. Boom. As soon as you see that, that's a keyword. Your mind goes straight to this formula. How much will you have in your account in 1 year, 18 months, and 5 years? So let's go through this. All you really need here is time. So time is always in years, and so that's 1. 18 months is what? If you do 18 divided by 12, it's 12 months in a year. It's 1.5, and this is 5. So all you're going to do for each one is you use the formula. So you invested 10,000. That's your P. That's your principal times E. Your rate is 8%, and all you're going to change for each one is T. So the first one will be times 1. The second one will be times 1.5. The next one will be times 5. That's it. Grab your calculators, punch it in. I didn't say it was hard, right? So 10,832.87. That's the first one. If I multiply by 1.5, 11,274.97. If I multiply by 5, $14,918.97. $2.25. All right. So that is how you use that formula. Let's do a couple of other exercises where the thing that you're solving for isn't the future value, but you're still using the same formula. So take a look at this question. How much time will it take to triple your money if you invest at 12% interest compounded continuously? They love questions like this, guys. So if they say to triple your money, to double your money, to quadruple your money, they're giving you the P and the A, right? They're saying that A, which is the future value, is 3 times the principal, right? That's what it means to triple your money. You have your rate, and they're asking you for T. And it's compounded continuously, so that's how I know I'm going to use this formula. So if A is 3P, I'm just going to substitute A with 3P. P will stay there. The rate is 12%, and I'm solving for T. Now, if you haven't realized already, we will be using logs here. So the P's will cancel out, and now I'm here. 3 equals E to the 0.12T. And then you learned, whenever it was that you learned logs, that if you want to cancel an E and bring down its exponent, all you have to put in front of it is ln. So we're going to do ln on both sides. This will cancel out the E. So now I have ln 3 equals 0.12T. Divide this by 0.12, and you have your answer. ln 3 divided by 0.12 is 9.16. So it'll take about 9.16 years to triple your money at this rate if you compound continuously. One more, similar. This time we're solving for the rate. You invested $4,000, that's your P. At X percent, we don't know the percentage. Compounded continuously, again, keyword. So now, okay, that's my formula, E equals P or T. It grew to this much, that's A, that's your future value, and it happened in 4 years. That's T. Plug it in. 58, 49, 14 equals 4,000, that's P. E, I'm looking for R, T is 4. And then from this point, guys, it's exactly like the previous question. You're going to simplify it, use a log, and you're done. So let's start by getting rid of the 4,000, so that's going to go away. If you don't mind fractions, I would say just leave it like that, okay? So now I'm going to do ln of this. Now, if you do mind fractions, just punch it in and keep a few decimal places, like 3 or 4. All right, to the 4R. So I canceled this and I ln to both sides. This will cancel out. Right? So now I'm here. Right? By canceling those out, I get this. Divide this side by 4. And you can punch this into your calculator exactly like that. ln bracket, okay? I'm telling you guys exactly what I'm punching in. So it's ln bracket 5849.14 divided by 4,000, close bracket, divided by 4. I get R of 0.095, which is, typically we like to express these as percentages, right? So it's 9.5%. That's it. So if you have any questions at all, please don't be shy. Hit me up right away. If you enjoy that and you want to work together, click on the link below to book a call and we can get started today.